Okay, in this video I'm gonna give you an introduction of ANSYS. Introduction of using ANSYS for a simple FEA analysis. Alright, so we are gonna use ANSYS workbench. So to do this analysis, so let me reopen workbench. Okay. Alright, so let's wait till it's completely loaded. Workbench. Alright, so this is the workbench environment. On the left side you see the list of all different types of solvers that workbench has, different types of analysis you can do and the solvers. We are gonna focus on do an example of a static structural. So a static structural means that we're gonna model the structure and the loading type is gonna be static. So the solver is gonna be static. Alright, so I double click on static structural and then you see this appears here under your workbench. Your working area. Okay, so in order to complete an analysis you have to complete all these tasks that you see here. So you have to specify engineering data, geometry, and then model, complete the model, then solve it, and then you're gonna see the result. Alright, by default workbench is gonna assume that we are using structural steel as our material. If you are not interested in strain and the only thing you want is the stress, then you don't need to actually change the default material to material that you're using your design, because the stress is not going to be function of the material. But if you want to know the strain and deflections, then you need to specify your material here. So you double click here. If you see here, structural steel is going to be your default material, but if your material is different, you can come here and you see structural steel is right now our default material. If you click on this plus sign here, the material is gonna be added to the library of your project. The properties are gonna be there. So I'm not gonna change that, but you see if you go here you have different types of material. Library of materials, you see gray cast iron, magnesium alloy, structural steel, as I said, is already here by default, but if you want to change it you just click on here on this plus sign and then that material will be added to your library of materials. Okay, so I'm not going to change this guy. By the way, let me make sure that my quality is good. Yeah, resolution is good, I think. Okay. Alright, so we don't need to change it. I click on geometry. I'm gonna double click on geometry, and here I'm gonna show you the modeling environment of workbench and see how we could define a new geometry and move on with your modeling. Another option would be sometimes right now it's opening it, but later I show you after you know, the environment is on. I will show you that, you know, alternative way is go to the geometry and import your geometry from other software such as like you know, SolidWorks or other CAD software. So this is the modeling environment space plane. You know, let me close this and show you that option. You know, when you right click here on geometry, you see one way to define the geometry or is to import geometry from other software. So I go browsing, and then if you go here, you see there are different types of geometrical files that ANSYS is gonna accept, and the one that is probably the most useful one for you guys is this guy, is SolidWorks part model or part file, right, or assembly. But if you click here, then if you have any like SolidWorks model saved here under your documents folder, then it's gonna appear here, and then you click on it and then import it to your you know to your model. But I'm not gonna do that, so let me again go back and double click on this guy, because I want to show you guys how to model geometry in a space plane. Alright, so let's wait again. Hopefully this will take less time this time. Yes, it did. Alright, so if you see here the environment of a space plane is very similar to SolidWorks. You know, I mean, you have like some, you know, for sketching tools, you have them here, and you know, here on the left side you're gonna see like a design tree. Alright, so I want to show you guys how we can model a simple bracket. So let me show you the sketch. So this lab, you're gonna model a simple bracket like this. So I want to show you how we could model this and then apply a load and then find the stresses. Alright, so to model that bracket, you know, that bracket, we need to start drawing it using a line. Let's review this a little bit. Look at the geometry. You see, I have like this length, this side is 0.75 inches, and then you have 2 inches going this way, and then another 2 inches, and then at the end you have 0.5. The radius, fillet radius, 0.125, and the thickness I believe is 0.2. So you know, so this is our model. We need to make it here. But before that, we need to make sure that our unit system is in inches. To do that, you click here, and then you go to, oh no, it was here. You go to File, click on File, Space Plane Options, and then for unit here, you see, click here. You see that right now the default is metric and millimeter. So, but I want to change it to imperial unit system. I'm gonna have length in inches. The like the load is gonna be in pound. All right. So I okay that. So this. All right. So now our units are in inches. Then I'm gonna start drawing that thing, right? So I had here, you know, I can start from here, from the origin, right? And then go this direction. You see I'm going to above and on to right, and that length was 0.75, so I can say 0.75. You see the direction is like I've selected that with, you know, with mouse, and then the length I want to have it 0.75 of inches. Alright, so that line is now 0.75 inches. So I right click here and I want to zoom. There's the zooming. You know, we can go zoom box, and I want to zoom it on this model like that. So this lens is like 0.75 inches, and then I'm gonna have a line that, if you remember, it was like we have to go 2 inches in this direction. So I put 2 inches here, and then I hit enter. Alright, so, and then if you remember, let me do other side too, you know, do another line from here up to here where the other line ended. And then what I had was the bracket end was 0.5. So the way we can do this, let's do so 0.75 and 0.5. the difference is what is 0.25. if I divide it by 2, it's gonna be 125, right? So I have to click here another line. I go in this direction. How much? 0.125. and then in this direction I'm gonna go 2 inches again, right? In this direction I'm gonna go 0.5, you know, you can input 0.5, and then you go here, go back here, and then I connect it here. So I have the bracket right now, right, almost I have it, other than the fillet here. If you remember, look at our design, you know, other than the fillet, everything is right? So here the radius of fillet is 0.125, so we need to put that fillet on our sketch, and then our, you know, in our bracket in 2D will be complete, right? So let me again zoom, right click, view, zoom box on that corner, and show you guys how we can put the fillet, right? Alright, to put the fillet, there are different ways to do that. You know, one way is, you know, we can do it this way. I do a circle, you know, that fillet I put here. This length was 0.125 equal to my you know, the radius of the fillet, right? So okay, one way is, maybe let me do this way. Okay, see, this one is gonna do tangent arc. So then you select this line and this line. See this line, right? And then if you look at it, the radius of the, you know, this line, tangent line, is like it's tangent. This is the curve is tangent to this line and to this line, but the radius, I don't think the radius was right. So I forgot this. You know, just hold on. Let me delete this and redo it. I'll delete this and redo that part. So tangent line, you select this and you select this, and the radius of fillet, now it's right, because you see this says the diameter is 0.25, right? So the radius of the fillet was 0.125, the diameter is going to be 0.25. So, you know, if I now hit enter, I have it right. Previously, you know, before I selected these two, but I had the wrong diameter or radius for my fillet. So now this one is right. Okay, so we have the right fillet, but what I gotta do here, I have to eliminate, you know, delete this line, and I need to delete this portion of this line, right? So this one is easy. You just select it and then delete that. You I click on it and I delete that. But for this one you can trim it, you have to trim it. So we can use this tool, trim away. Let's see, which one was it? Trim, this one? No, this one, trim away. So trim away one, if I select this, now you see it's automatically understands that I want to eliminate this piece, which is like after intersection of this line and this curve. There is like after intersecting point. I need to remove the residue, right, of that. So this is how you do that, using trim away. It's very smart tool. It will automatically identify the potential like lines or extra geometrical properties, entities that you want to eliminate, right? So this is done. As I said, there may be different ways of doing it. If you doing this fillet, I could let me do the other side. We need to do the fillet on the other side. I do right click, zoom, and then I do zoom extend, and I'm gonna right click, box zoom on that. This time I want to do it differently, right? The fillet, I'm gonna do it differently. I'm gonna select this point and then have it circle that has diameter of 0.25, right? So this is the fillet piece. This piece is the fillet piece that I need to keep. The other features I need to eliminate, right? So let me eliminate, let me use the trim away tool. So I click here and look at this. ANSYS is smart, I go on that, I hover my cursor over that, it automatically identifies that I need to eliminate that, and this one same thing, and this one same thing. So you see I did this one in different way, right? There may be other ways to do this, but I showed you guys two ways to do that. So now I have my bracket, right? So but the thing is, our bracket has also a thickness. Right now I have a surface model, right? But the bracket has the thickness. The thickness was 0.2, right? Okay, so you know what? You can also double check your model by, I want to see the lenses I have here. See, make sure that it's right. You see this line length was supposed to be 0.75, which is right, and then you can do this one 0.5, this one 2, this one is it was 2 from corner from here to here, but now the fillet has reduced the length of that line. And then this fillet, you see the arc radius is 0.125, so it looks like model is right. Okay, so you can come here, as I said, it will show you measure, and then you can look at double check your model. Next, I need to add thickness to this. Right now it's a surface model. I want to convert it to a solid model. So how to do that? In SolidWorks, the word we use here, the command you use is extrusion, right? You do extrusion. But I'm gonna in here in ANSYS, the command is pooling. So you click on pooling, right? And then when you click on pool is like a word, is like a command you have in workbench, but extrusion, revolving, and sweeping, are the commands like that are all of them are considered as part of pooling in ANSYS Workbench, but in SolidWorks, you have them as separate commands. Okay, so you see this one, it says pool direction. This is more like extrusion. This one is like revolving, what you had in SolidWorks. This one is drafting. This one is sweeping. So we may use them in future in other labs, but right now I'm focused. We're gonna use this guy, pooling, which is more like extrusion. So I click on the surface and hold it, and then I drag it up. Right, I drag it up 0.2 inches, or you can input the 0.2 as your length dimension. So now our geometry is complete. Look at the left side. I have a solid model now, right? So the next step would be for us to go with next steps, right? So geometry is completed in an FEA analysis. That's the first step, and then next we have to go to model and then mesh it and also apply loads. So double click on model and let's see what we get. You have to wait until this model opens, and we're gonna have to move with other steps. Alright, so we have to wait a little bit. Okay, it's on. Oh, one thing I want you guys to notice is this, that after I completed the geometry, you see that check mark appears here. So this is how Workbench is telling you that geometry is done. So next step would be modeling. So it's opening now. Let's see what happens. Hold on. Alright, so this is the geometry that came here. Okay, so next step, you see on the tree, modeling tree on the left side, when you see check marks, means that those steps are done, and we need to complete the ones that you have that yellow thing next to them. Okay, so material, as I said, structural steel is the default, and the properties are listed in here, right? And let's do meshing. You right click and then generate mesh. Alright, so this is like a randomly generated mesh. You see it's kind of coarse. I mean, like we have big elements. And alright, but for now let's say it's okay. Alright, so we have our model. Then next step, you have the mesh, you have to apply loads, right? Alright, so how to add the loads, or we have to also constrain our model, put enough support. So you right click and then say insert, and then we are gonna fix the model must be in equilibrium, so we have to put sufficient support. Alright, so let me go back. I don't have a mouse, I'm using touchpad. I'm gonna use a fixed support on this left side. Okay, so on the left side, so see how I can yeah, we are gonna click. I'm gonna select a face, this face. See, I came here, clicked on face, click this face, and and then you see on this here, on this window, this say apply. So I selected a face and then I applied fixed support to that. So when this this purple thing appears here, that means that that face is fixed now, right? I'm gonna rotate this, and so I have fixed support on the other side, but I want to apply a load here to this face. So to do that, you go here, right click, insert, and then say I want to apply a force. Then it says okay, where you want to apply, we have to select this face. I'm going to select this face, this guy, and then say apply. So the face selected, but you see this yellow thing, we said that we apply a force there, but we didn't say how much is the force, right? So for that, see, you have to put it in. It's asking me to do it in newtons. If I want to do it in newtons, 10 pound force is equal to 40. It's like, okay, let me see. Excuse me. 10 pound and newtons. I want these exact numbers. 44.482. Alright, that's our load. And something you guys have to be careful is that, you can define it as a vector, or you can define it based on component. I had to do this first. So if you do components, you saw that that face was x-axis was perpendicular to that, so by default it did apply that load along x-axis, right? So let me but the better way to do that is this. So you can apply the load like a vector to that face. So that face, as I said, is perpendicular to x, so my force is gonna be actually along x-axis, so 44.482. Alright, so this is my force. I applied it there, so this is it, and let's solve it, right? So to solve it, you see, only thing that remains is this piece. You can come here, click on solve and solve it. You can here right click and say solve. Either way, it's going to solve your model. It's solving it, and when you guys see this check mark, that tells us that the solution was done. Okay, so but we have not asked okay, if you come here and then you look at the end, it's gonna tell you that how much time it took to solve it, and it took us 4 seconds to see it, but the CPU time was actually only 0.9 seconds, so less than a second. And then it gives you some, it's like the log. It's like your log file. It tells you how many elements you got and other information. But what I want to see, I want to see maybe stress and other things, right? So if you want to see the stress, you right click here on the solution. Solution is done, but we don't see any result here. We need to specify what we are interested in, and then see that, right, and report that. What I always do is I go to deformation, and first I look at the total deformation, because that something tells me if the model was right or wrong. Look at here. The red means that I plotted deformation, so that's like displacement of every particle on this bracket. Obviously that left end was, if you remember, was fixed, So those particles close to the left and they are not gonna move much, and the ones on that face, on that left end face, it's gonna be zero. Displacement is gonna be zero. You see the color. On the right side, I'm gonna have larger displacement because that end is free. And I always look at the animation first, and because that tells me how healthy my model was done. You see, looks like, you know, with that model I had in my mind, this is what I expect to see, this to be deformed, right? And so that gives me kind of reassurance. And by the way, this is like exaggerated displacement. Then in engineering structures we don't have displacement like this large. So what you see here, if you look at here, it says that it's like 18,000 times of the real scale, you know, the displacement you see here. If I do it through a scale, right, then look at our deformation. You see, we almost see nothing. This is what happens in engineering structures. You know, I mean, displacements are small, right? Yeah, but auto scale, it was like, as I said, 18 times. You can make it even more. This is like 5 times of auto scale. So now let's look at deformation. This is not realistic, but it gives us idea how this works. Alright. Okay. Then next thing I do is I go in there and I plot stresses in X direction. Right? I want to see normal stresses in X direction. So how do you do that? I go here, right click, no, and then you go stress and then normal, right? By default, you see it's gonna show me normal stresses in x-axis, along x-axis, right? But if you want, you can change it to y or z. I'm interested in x-axis, so I leave it on and then right click, evaluate our results, and this is the distribution of your stresses, you know, normal stresses. And you are interested oftentimes in maximum value, right? And you want to know where the max occurs. So if I click here, it's going to tell me that the maximum is going to happen here, right? And how about minimum? Minimum happens here. This is what we expect, right? Stress, you're going to have a stress concentration here, so that's what you see. And you can use this feature probing. I don't like, you know, looking at this legend here. Yes, it's okay, it will give you a good idea how the stress is distributed, but if you are interested in numbers, you want to know exactly how much is the stress at a given point, you click on probing and then you go here and then click wherever you are interested. You click here, you see my stress is 800,000 Pascal. Click here is 400,000. Here is 600,000. Make sense? So, right, this is how you guys can do that, by probing. Alright, and what else? Okay. If, as I said, if you want to interested in other stresses, let me eliminate these guys. So I had the stress in X direction, I had X direction. If you're interested in other stresses, or if you're interested in a strain, for example, you can go here, normal, and then do that. So let me go back again. I want to look at it again, a stress in normal direction, normal stress along X again. Evaluate, and this is what we got. Alright, so you saw that the mesh wasn't really a good mesh. I mean, it was coarse, right? So what I'm gonna do is I want to refine the mesh. I want to show you guys how we can make a smaller mesh. You come to the mesh, right click, go insert, and then you say I want to do refine mesh, right? Refinement, and then it says geometry, select the geometry where you want to do refinement. I'm gonna right click here and I say I want to do it on all faces. All faces I want to see refinement, and then I do right click, and then I click here, and then I say apply. 10 faces selected, and refinement level can go up to 3. Right, so let's say I want to do refinement level 1 right now, so I just leave it 1, then right click and I say update. If I say update, everything is going to be updated, you know, I mean the mesh and the solution. Okay, if the solution is not done, you do this again, right click and solve it, and solution comes out. Alright, you know, I'm interested in seeing the CPU time, you know, yeah, you know. Okay, so with the refined mesh, you see our stress distribution now, and what you guys see, the stress has changed, right? And again, the maximum is here, it happens there, and then you can probe it. Here's my stress. The stress is far from the point of, you know, the stress concentration is this, and here's that. Alright, so let's keep our eye on the maximum one. The maximum stress is this value, right? It's in table 2. So it's like 1 megapascal, right? Something like that. I want to keep refining and see what happens. So you go to refinement again, you click here, you do 2, and you see what happens this time. You solve it again. So refinement level 2. Alright, so you see it was refined further, right? And the stress has changed, right? So that means that, you know what, rule of thumb is if you see more than 10% change, you keep refining until you see like your result becomes stable. So right click here and then update. So this is really fine mesh now. Just hold on. Yeah, is it done? Not yet. So right click. I'm sorry, click on solving. Alright, so you see what happens now. Look at our model now. The mesh is more refined, right? And then the stresses this time, I think it changed less. Alright, so this is how you do refinement automatically. There are other ways of doing it. One way is this, you know, you say, you go insert for meshing, you say I want to select the sizing, then you say right click, or for geometry you say selecting all, and then element size, you see default is what, 0.005 meter, but you know what, you can make it like, instead of 0.005, you say no, I want to make it 10 times smaller, right? This is gonna result in much smaller right? So you know, 10 times smaller than the automatic one. Say, see what happens now. Right click, and I want to look at the mesh. But when you are doing this, you gotta be careful You gotta be careful that not hitting our software, our license. Our license is limited, is academic license is limited to 20,000 I think elements. So if you hit that, then it's not gonna solve it for you. So I am not sure right now if we have hit 20,000 or not, but obviously you guys see the model is you know, the elements are much smaller than before, right? But you know, try to solve it, see whether we hit that or not. If we hit that, it's gonna say sorry, no solution. But yeah, so let's see what happens. I don't think we hit that 20,000. Let's see. That was another way of refining the mesh. Or a smart FEA engineer, he's not gonna waste his resources on places he doesn't need. Yeah, apparently we were able to solve it. So what I mean by that is, you know what, you need refinement in this region. So why you do refinement here? It's like wasting your resources. So it's better to do it around here, only refinement here. But we are not gonna go that far here in this video. So I just showed you guys, you know, that with that other way of refinement, you see what I got. And the stresses changed. The maximum is gonna happen here. Oh no. Oh, okay. I see what the problem is. The max that we have here is happening here, right? Where you have the fixed support. But we know we are not interested in that section. We want to see what the maximum stress is, where I know we have a stress concentration. So in that part, in that region, you know, it has not changed much. Alright, so this was like just a demo. How do refinement? So I went back to that crude coarse mesh that we had at the beginning. I went back to that. Alright, so part of this lab is also asking for, you know, altering the support at the end and see what effect is gonna have on your results. So let me tell you what I mean by that. So as I said earlier, a static structural model must be constrained or fully constrained, and you should have equilibrium in your model in order to be able to solve it. So if you don't have sufficient support, then the model is not going to be able to solve it. Let me, you know what, remove this support here, fix support here, and see what happens. If I solve it, it's not going to solve it. It says not enough. You saw the first message it gives us. Not enough constraints appear to be applied. So what does that mean? It means that, you know what, this model is not appropriately fixed and supported. So that means that, you know what, this is not static structural. If you apply this load and it's not constrained, this bracket is going to start moving and the ANSYS is going to get confused, right? So we needed to support that. We need to have sufficient support to do that. So part of our lab says that you guys go and you have to change like the support and see what effect is going to have on the stress. I use the fixed support at that end, right at that at this end. I fix support here. It's asking you guys to try different types of supports and see what effect that's going to have on your analysis. You know, let me try another type of support. You know, right click here and I'm gonna apply displacement type of support. displacement boundary condition. Okay, so I'm gonna select this face and then say that face, let's say, is not gonna move in x direction at all. So I put here 0 and then I say, you see you have check mark. So what does that mean? That face is not gonna move in x direction, but it's gonna, particles on that are free to move in y direction or z direction. This model right now again is not fully supported because why? Because this bracket is not gonna move in along x axis, but in y z axis is gonna move. So if I try to solve this, guys, again, not enough constraints. So right, you can go back there, say on that face, you know what, on that face, let me redo it, say what, how we can change, yeah, we have to redo it. Okay, I right click on it, say delete, then right click, insert, displacement, right? So I have to fix x, y, z. So you can come here, say 0, 0, 0. Then that will be equivalent to what we had as fixed support, right? So, but now I'm gonna do it differently. You know, I'm gonna say that face, I select it, but I'm just gonna select fix it in 0. But the thing is now, this bracket is fixed in x direction, but in y and z you have to add additional things, right? Additional support. So I go the displacement, but this time I'm going to select the corner. So you see here, vertex, I select this corner. You remember that face gives us support in x direction, but when it comes to that corner vertex, I need to fix it. I'm gonna fix it in y and z. So already it's already fixed in x direction. So I'm gonna select it in y and z. I'm gonna fix that in those two directions. All right. So okay, now this bracket is fully supported because it's not gonna move in x and then direction because that face is fixed, and then that corner is fixed in what, y and z. So therefore this is fully supported. So now let's run it again. I'm not getting that error. This time I got a, did I get an error? Let's see, x is free, you know. Okay, let me make this one 0, 2, I think. Then see what happens. Okay, let's double check this. This one is fixed in x direction. Okay, I think what the problem is, you know, if you're fixing it like a just this point, and then it's causing the solver to not to be able to solve it, because if you just fix one point, you're gonna have large deformations around that point. So it's because of that. So let me remove this. Alright, so this face is fixed in x direction. Let's say I'm gonna select edges this time. So you can come here, select like, I don't know, this edge. Yeah, this edge. Let's say this edge. Let's say right click, displacement, all points on that edge. Hold on this edge. Let's say they don't move, they already don't move in x direction. Let's say they don't move in the y direction, right? And then I'm gonna select another edge, this edge. No, not this one. Okay, you see this thing, this appears here. because the ANSYS is confused which edge I'm talking about. So if you click on this, you see it's gonna switch between those guys. Let me zoom in, you know, you need to zoom in. Box zoom. To appropriately select that guy. And let me delete this and redo that, please. Right click, insert, displacement. I'm gonna select this edge. So you come here, I'm selecting this edge. Okay, that edge, I'm gonna fix it, let's say in Z direction. So this edge in Z, this edge in Y, and that face in X. So we should be fine now. Let me check. Alright, so because we have enough support, alright, yeah, it solved it. So now look at the stresses, right? You know, this new type of boundary condition or support I put on this end, it kind of relaxed the stresses around here, right? And that's better modeling now because the max is happening here. See what I'm saying? Max is where I was interested. I was interested around this point. I was interested around stress concentration was here. So this is kind of better modeling, right? So let me probe. Stress here is this much, stress here is like this. Stress concentration is gonna be what? This is stress divided by this is stress. So for right now, what I'm getting, if you guys divide those two guys by each other, is like 9.547 divided by 6.897, 1.4. So right now stress concentration is that. So you know, as I said earlier, if you want to add refinement, you know, select right click and then say select all, refinement level 1, right? And then you keep doing this. See how stresses are going to change. Go to the stresses, right click, solve. Right, the max probe, the stress here 691, stress here, yeah, the max is this value. You have to see what the max is, and then divided these two guys is going to give you guys stress concentration, right? So you see stress concentration changed a little bit. If I increase the refinement level, let's see what happens. My stress, yeah, you see stress concentration now changed. My max value is 1.22, and you know, here is 6.9. so stress concentration changed a little bit, right? So you know, you have to keep doing refinement until you have like good convergence or like stable results. You can also do mesh refinement on refinement. So let me see. If I come here and say I want another refinement, then you select all faces again, number 3 again, and then see what happens. Yeah, so then you look at the solution again, you know. So other way was the way I did for you guys earlier, you know, by selecting the right size. See, the max is here again, that value, right? or so you guys you have to keep doing this, and you know, until you have a stable result. And right, then you can get closer. Your stress concentration is going to be closer to what you see in reference books. Alright, select all, element size, you know, as you saw, I made it like 10 times smaller than, oh, now it's like 100 times, 10 times smaller than the default. Let's see, let's look at the results now. You remember last time I did this analysis, the max happened at that fixed support, so which wasn't something we were interested, right? I mean, we don't, you know, the max was reported here last time, but after changing my boundary conditions, see what happened now. Okay, it's taking long the other time. Alright. Okay, yeah, you see this time the max is not happening at the end. It's happening here because, as I said, the new boundary type of boundary condition I put kind of relaxed stresses here, and my max went to a place that I was, you know, I was expecting. So that's a good thing. I mean, you see the results are quite stable now. Alright. Alright. So this is it. I hope this was a useful video for you guys to, you know, to do your first FEA analysis using ANSYS workbench. Alright. I close that. Now look at here. You know, you have all check marks. That means that the model is completed. We have also results and solution, everything there. You can then save the project, right? So if you say introduction to FEA project, and you go on desktop and save it, right? Let's say you want to share your model with your friend. You see, I have introduction to FEA file, workbench file, and then you have all these other files that, right, is actually, it's like this is like the parent file, and then these are all the children files. So you cannot just move this file to a new computer and run it. You need to have these children files too coming together, right? You see the size of it. This is 123 megabyte, and this guy must be smaller. This is 44 kilobyte. This file actually is a workbench file, and it kind of relates, is like inside this file shows the relationship between all these files that are saved here. Alright, so in future, if you want to run your file again, open it, you just double click on this and it's gonna open it for you. Alright, and alright, I hope this was useful. Again,